Hi everyone, we're going to evaluate this given integral using trigonometric substitutions. So it has the form of x squared minus a squared. So we're going to use secant, and these are our restrictions here. So what we're going to do is let ax equal b secant of theta. Because see, we have this extra constant here. Now, when you do that, you're going to get ax squared equals b squared secant squared theta. So that's going to equal ax squared minus, if you subtract b squared from both sides, which is what we have here. So I just subtracted this from both sides to make it look like this. You're going to get b squared times secant squared theta minus 1, which equals b squared tan squared theta. Now, when you do the square root of ax squared minus b squared, we're just going to get b tan of theta, because you're taking the square root of this, and then you can simplify this as b dx equals b divided by a secant theta tan theta d theta. All right, so now we can go ahead and integrate this as, and we're going to do substitution, the integral of, we had dx, let's just write this again, dx divided by ax squared minus bx squared, and this was square root, and the whole thing was cubed. So we know that dx was b divided by a secant theta tan theta d theta, and then this whole bit here was just secant, was just tan, so we get b cubed tan cubed theta, and here's our d theta. All right, so let's pull everything out. This here simplifies as, let me put an integral here, 1 divided by ab squared. Okay, and then we can simplify these tans here, and you're going to get secant theta tan squared theta d theta. All right, so this is going to simplify as 1 divided by ab squared, and then if you simplify this, that's just going to be cosine theta sine squared theta d theta. All right, and if we want to integrate this, the best way to do it is write this. Let's see. I can write this as cosine theta divided by sine theta times 1 divided by sine theta. So that's going to give you, this piece is just going to be cosecant of theta, and this piece is going to be cotan theta d theta. So the antiderivative of this is just negative cosecant. So what we get is negative 1 divided by ab squared, and the antiderivative of cosecant cotan is cosecant, or negative cosecant. plus c. All right. Now, we started with x, so I'm going to draw a little triangle. I put my angle here, and we let x equal, or ax equal b secant of theta. So when I fill this in, I'm going to get secant is going to be ax and b, and this is going to be square root of ax squared minus b squared when you do the Pythagorean theorem. All right, so, and this was a b, sorry. All right, now we have to fill everything in, so when you fill everything in, you're going to get negative 1 divided by ab squared, and you're going to have ax for cosecant. That's going to be your hypotenuse, ax over adjacent, which is going to be square root of ax squared minus b squared plus c. So let's simplify this further. The a's cancel, so you're just left with x. So we have negative x divided by b squared times the square root of ax squared minus b squared plus c. And that's it. Thank you. Have a nice day. Bye-bye.